So repeating, I'm going to talk about a almost controlless approach to UIs that you're going to look at it and say, yeah, no, there's a lot of controls right there. So to introduce myself, who am I? I'm a certified LabVIEW architect. I've been a LabVIEW architect for well over 2 decades at this point. I'm a LabVIEW, one of the newer LabVIEW champions. Some dog rescues call me their doggy doula. And there were complaints at last month's GLA summit about me not having enough dog photos in my slides. That should be resolved for this presentation. I'm also a shark at the Jaws on the Water events for Alamo Drafthouse, where people sit in the water in inner tubes watching the movie Jaws, and I scare the hell out of them. Speaking of puppies, Darren wins for his presentation yesterday of having the most puppies born during his presentation yesterday afternoon. I'm happy to welcome 7 new lives into the world. Names are still to be determined. I taught this particular foster what to expect when their dog's expecting last Friday. So 7 new lives in the world yesterday. And Darren wins, and my wife wins because she was the helper that went over to provide support, and 4 of the 7 were born while she was there, and only 3 the next helper. Our giants are female. I want to talk about Ann Levinson. She was my honors and AP chemistry teacher and had a very interesting approach to teaching. We had labs such as the partial thermal degradation of polysaccharides, which is to say we learned how to make peanut brittle. She would start every year of the class with an introduction as to safety equipment, specifically your masks and the importance of wearing them during experiments. And the way she did that was to start talking about it. Another teacher would come into the room, start rifling through her desks. She would confront them. They would pull out a pie and throw it in her face, at which point she would take off the safety goggles, showing that her eyes were entirely untouched. She would also get the high school students to help with education for younger school students. We would go to middle schools and do things like pH experiments where we made pH indicators using purple cabbage. Purple cabbage with water is a good way of seeing different pH. It changes colors. We'd also teach kids about MERS. You'd hang a sign on one kid's chest saying MER. You'd put another one on a second kid, and now you've got you'd have a monomer, a dual MER, and get all the kids together, and you've got a polymer. So very interesting individual. When I took AP chemistry with her, she had yet to have a student get a below a 4 on the AP exam, including students who would get a C in her class. So she knew her material, and she brought it to us. So I'm going to start off not with talking about the software, but I'm going to start off with demoing the software. So give me a moment to set my virtual machine over to dual monitor mode. Oop. And so 2 years ago, I started having the need for projects that used a bit more in the way of graphics and a bit more in the way of displaying information to users. And so I designed a toolkit for internal reuse, but due to timelines, mostly subcontracted it out, and came up with a way of having a different approach to UI design. And so this is actually running on these 2 C-RIOs right now. One of the C-RIOs is my customer system. And the second C-RIO is a simulator that takes the inputs and outputs. It also simulates the motors in the system. It simulates the temperature controllers. So there's actually a whole bunch of serial cabling inside, mimicking the controllers that my customer would have. Now, this represents a V100 semiconductor system, a molecular beam epitaxy system used for growing the crystals used in semiconductors. The V100s originally debuted in 1989 as the first semi-automated molecular beam epitaxy growth chamber. The external hardware, the chambers, are stainless steel, designed for high and low temperatures, designed for high and low vacuums, and last forever. The electronics don't last quite that long, so my customer is actually rebuilding all the electronics right now, and so we're redoing all the software and hardware with C-RIOs. And so we're able to do things such as tell the system, the chamber I'm clicking here is what's called a fast entry lock. It allows the operators to load the platins that they'll be growing the crystals on. And I can go ahead and tell them, let's go ahead and move this down to the Y3 position. It'll look a little bit jerky on the screen as it brought that fast entry lock with the 6 platins in it down, because my simulator, when I tell the motor to move, it just immediately goes to the target position. In real life, that would take some time. You would see that the platin carrier moving down slowly. Likewise, we can move to different positions, or I can bring it back to unload, which is the top position. Likewise, I can bring the trolley, which you can see in the center right of the screen. I can bring it over to the outgas position. And you may see different of the text on the screen changing color as different of the sensors move and bring condition of the system. Likewise, I can go ahead, open my main gate valve, open my cryo valves. Where's my cryo? Pump 1 valve, there we are. And so I've gone ahead and opened the valves on the system. So I'm displaying a lot of information to the users graphically. Let them know where different things are in the system, because this is a stainless steel chamber. It has some windows looking into it, but if we look at some of the other systems the customer has, there's the R49s, 49NTs, the 6000s, when we look at the user interface, we don't have a good idea of where any of the motors and any of the arms are inside the system. And so I wanted to fix that for this project. So I'm going to go back to my slides for a moment. How many controls do you think were in that GUI with everything you saw? Sam, you're not allowed to answer. You've been seeing prototypes of this for a couple of months. Everybody saying 1? Not quite, but we're a little bit more than that. So what controls were in that VI? There's a .NET status strip at the bottom. There's a splitter bar, so we can argue whether or not that counts as a control. There is a tab control because as I'm doing a lot of the things graphically, as I build up the graphics, I also want more traditional controls in the background because this is a newer tool set, so I don't have everything involved. So there is actually a bunch of hidden controls primarily for diagnostic purposes. There's a multi-column list box. And there's a subpanel, and that subpanel gets a single 2D picture control. That single 2D picture control is what is displaying all of the buttons and almost all of the information to the user other than that multi-column list box. I have used this on 2 other projects to date. One of my customers has a universal gas panel tester, and the universal gas panel tester was the very first multi-person project I had as a project lead, as a project manager back in 2004. Back in 2022, I was hired to redo it. It lasted 18 years, so had a good thing. But the original implementation, based on what we had available in LabVIEW 7.1, was for the test admins writing all of the variations on all of these gas panels, we would have a cluster of clusters of custom controls. And so you needed a LabVIEW developer module to create all of these, to create all of these panels. Every test had a unique panel, couldn't modify it on the fly. And if we ever changed any of the type defs, back then, JSON wasn't a thing, XML wasn't a thing, it was all binary. And once we were in, we were pretty much locked because we would break all of the configuration files if we changed any of the underlying type defs. This is one instance. We have a couple dozen valves. We show some pipes. We show some others. We also show, and unfortunately they did not give me a high quality screenshot. We can also see where we have, in this case, we've got a number of mass flow controllers, and we're showing text for the pressure, the volume, the flow rate, the set point. And this is all dynamically generated now. I have a UI that my customers can use not only at their desk where there's a LabVIEW development environment, but on the floor on every single machine to go ahead and create a new gas panel if some of the documentation was wrong and what's on the floor doesn't quite match the reality. Another project that I have is what's called the MBE software, or Nova Molecular Beam Epitaxy. This is software that is also under development, and here is, let me move this paper so the mouse works a little bit better. So this is the live screen that the customers get access to. Every customer is able to configure their molecular beam epitaxy system a little bit differently. And so we can get multiple copies that are configured for each portion of the system. So the degas chamber has a single heater available to the user. In this case, some of them will have a couple of additional indicators, but every one of these can be changed at runtime based on the user configurations. And I'm going to say at runtime to a certain extent, and I'll get into that a little bit later. So what I did is I had a software reuse library that I call the graphics utility. It utilizes the 2D picture control, and I create a config file that's a display configuration file that is a collection of objects. The objects may be singleton type objects, which can include text, decoration, or images. It can include compound objects, which can be a link to an image. It can be a link to a subconfiguration. It can be a link to a multi-state control. So I can build not binary Boolean buttons, but I can have tri-state, quad-state, quint-state controls as well with this. I can also have a display configuration, and the display configurations are recursive. So the mass flow controller that we saw in the screenshot from the UTF is a configuration that has an ID, which is a text object. It has a max flow rate, which is a text object. It has pressure, flow, set point, state. It's all black in this screenshot, but when the flow rate is 0, set point 0, it's black. When you have anything going through it, it turns green. So we've got an image plus 5 text objects. But then we can do this recursively. I have my MFC, which is a display configuration in and of itself. I put it with a stick and add on a couple of valves, which are some display configurations. And then I create a display configuration of the display configuration to give the ability to build things recursively. So in this case, I've highlighted a couple of objects. There's the MFC stick, which all it has is it has the MFC plus 2 valves. We have the valve stick with a transducer, which has 2 valves and a transducer. Depending upon the system configuration, they have a couple of different of these sticks that they then build into the larger panels, so that they get a lot of reuse out of the configuration rather than having to, every single panel, say, okay, I've got a stick that's got two valves, a transducer. I've got this next one. Let's add a valve. Let's add a transducer. Let's add another valve. It's recursive, so you can have building blocks to more easily reuse your information. Programmatically, there is an API that I'm able to dynamically build code and build these configurations on the fly. And we also have an editor. But the fact that it's all done through the API, that the editor uses the API and the API is exposed to our end users, means you can create your own configuration utility that restricts to what you want for your end user. So I'm not going to go, because of time limitations, I'm not going to go too deeply into all the data types, but for example, on image name, you're able to specify the display name, which is being used under the hood. You're able to select the display object type, which is image. We can set whether it's enabled or not, so any images can be turned on and off on the fly. You can set the X offset, you can set the Y offset, and you can select the image. So you can also change out the images on the fly. Ways to use. I have two ways to use this. The first is a 2D picture control. You just put the 2D picture control, you make up your configuration, and you wire our display VI to the 2D picture control. But we also have an API for an insertable subpanel with events, and so you can register for the events in your own code and handle if a user clicks, if a user does a value edit, any of the text boxes can be made editable. So unfortunately in the live code that I'll be using, or that I've demoed, we haven't made any of those editable, but on the gas panel tester, you can click on the MFC flow rate, change it to 0%, type in 15%. We get a value edited event and can send that off to the actual hardware. We also have an error event. I have yet to manage to generate an error through that event, so that's a good thing. Tools. Within the utility, we have three primary tools. There's a control editor, a simulator, and a graphics editor. Control editor allows us to create multi-state controls. They can either be Boolean or U8s, and you can specify a different image to be used for each of the values. So if you say, I want this to be a quad state control, you can have it do 4 different images. And so anytime you do an update and say this data item is now value 3 or value 4, or you can respond to click events, use and increment each time, or decrement, whatever you want to do. The control editor allows you to say, this is the control file I'm saving. These are the images it refers to, and add some, and we have the ability to change XY offsets if you need to align things a little bit. Before I get to end user editors, let me show you the other two, the simulator and the, let me get back to my virtual machine right here. And so if let me show you the graphics editor as well as the simulator. So the graphics editor, and this, once it launches, and okay, give me a moment, I just, doesn't like launching if I have the debug version of the application open. Give me 1 second, because I think I'm gonna have to restart LabVIEW. Or at least close the project and reopen the project, unfortunately. That's more a bug of the example VIs that I'm using to launch the things that they're all launching the same instance rather than launching different instances. So give me just 1 moment to reload this. And so if I launch the editor, it'll of course launch on the other screen. And I can go ahead and, oh, this is, okay, file open. And I'll bring up my V100 display configuration file. And So what I've done for this particular project, get the mouse here, is these are all the different objects that are being displayed to the user. These are all the text boxes. And the thing is there's actually multiple layers. There is a Z order, and the Z order is based on that list you see in the background. And so what I'm doing is I actually have the ability to track where the user is clicking. And so this piece, which will come up and down, that piece which will come up and down, I know what the user has pressed on, and it tracks it as it moves. It works with transparent PNGs, so if you have, and it's going to go to the layer below if it's transparent. So I know when I actually have to have my background not be transparent so that if I want them tracking, if I want to detect when they're doing the background, I have to have it 1 pixel off transparent. Within it, with the editor, you get to see all of the properties. You can change them here, save your configuration file. There's a simulator. The simulator lets you see as the user clicks the various buttons, clicks various places on it. I'm going to not do that based on time remaining. You can create your own custom editors for the users. So here's 2 examples in the same program of custom editors where if the user says, I want to create a Boolean display object, we expose certain information to them, allow them to do it. If they want a text representation, we say, here, you tell us the data source, you set the XY, here's the information for you. Some limitations in the current tool. It's 2D picture control based, so it is not vector image based, but it is still easy if you want to support multiple screen resolutions. If I want a 1920 by 1080 versus a 1280 by 400, choose 2 different, create a display config for one resolution, create a display config for the other resolution, detect what you're on, load it on launch, and all of your buttons, all of your tracking works. So not vector image based. For drawing text at point, because the underlying LabVIEW VI doesn't work well for multiple lines. It doesn't align. If you do center alignment, it's doing center alignment overall, and all of the text is left justified, but the text itself is center aligned to the point that you got it at. So work around, break multiple lines yourself, and also use some spaces. Would you use this library if I publicly released it? Let's see a show of hands. Does this look interesting enough? Yes, it does.
Can I talk to you in a couple weeks?
Yeah. It is not well documented. I need a cleaner API around it than my subcontractor provided, because you have to know that, oh, hey, my name is supposed to be, if I want to change something on the fly, my name is supposed to be like object name, pipe, value, or x underscore offset. There's some other stuff that I would need to make it a little more user-friendly, but definitely happy to talk about it more. Also, I did arrange for one of the breakout sessions to be me at the back of the room when we'd go to the breakout session. So if you want to come and see more of this, I am happy to do so. And 1 minute left. Pulled it off. I got rid of a lot of slides last night. Any questions for me in the minute I have remaining?
Any chance to make it stretchable to an arbitrary size of the window?
Yes and no. Because it uses a 2D picture control, it's not vector-based. With that said, there is code inside it that if you're choosing to use our subpanels and just bind us into a subpanel, the code is smart enough to look at the size of the image you have created and decide whether or not to show the vertical and horizontal scroll bars. And you can, of course, resize the pane. You can resize the pane based on your own needs. I don't think we're exposing, or we are definitely not exposing. We do detect panel resize, and I do partially use that to determine show or hide the scroll bars. But in terms of saying, oh, hey, let's swap out some of these pictures for slightly wider ones, you can definitely do that. We don't have a mechanism. I don't have a mechanism in place for that at the moment. And time perfectly.